Okay, welcome to another week and another session. This week, the content of this presentation would may also apply to the coming week, but we're going to continue to build upon the various study designs that we employ in epidemiology to address health problems. So let me quickly give you a quick summary based on what we covered the last few weeks. Remember, we started off with the descriptive study designs, and this week we would actually be going into the analytic arm. But before I do that, we have to remember that descriptive studies, address the person, place, and time, which would be the who, what, when, and where. And usually, what we're actually the measures of epidemiology that we're actually able to employ are measures of frequency, which would be prevalence and rates of exposure or outcome. Under the analytic arm, we're actually able to do more, right? It addresses the how and why, and in this case, we can actually employ the measures of frequency and measures of association, right? Which would be prevalence, incidence, rates of exposure or outcome, and also relative and absolute measures. And remember that under relative measures, we have risk ratios, odds ratio, and we could also have the standardized mortality ratio, which are the ones we frequently use. And then we have the absolute measures. Remember, for absolute measures, it only applies to risk, which means you can only estimate the absolute measure if you have a prospective setting, right? This is where we would actually be able to measure the attributable risk, or what we call the risk difference. Again, reminding you of the factors to determine which study design to use, which would be the research question or the objective, what the feasibility is, taking practical and ethical considerations, and also the frequency of exposure and outcome of interest. So these will kind of help you determine which study design to use. So now let's talk about the analytic epidemiologic study designs. This presentation will focus primarily on the case control and the cohort study designs. Again, remember, while they fall under the analytic arm or branch of epidemiology, they're considered observational study designs, reason being that the investigator or the researcher does not have a control of the environment. All he or she does is observes what happens in the natural environment, focusing on the exposure and the outcome, and all they do is observe and, try to link that relationship together. Again, so this is really observing what's happening in the natural environment. So let's start, let's look at retrospective and prospective. Case control study designs would be considered retrospective because in the case of case control studies, the outcome has already taken place and now you're trying to backtrack to a particular exposure, right? That's why it's retrospective. Prospective, on the other hand, also known as a longitudinal study, actually starts with the exposure and moves to the outcome. And you have to realize that there are some instances where you might have a retrospective cohort study. Where this differs from a case control study is in where exactly the study starts. If you're starting with an outcome and trying to identify the exposure, then it's a case control study. If you're starting with the exposure and tracing it to the outcome, it will be a cohort study. Okay, so those are the two main differences there. Pay attention to the direction of the arrows. So let's go into case control study designs. What is the hallmark of case control studies? Can you tell me what that is? Based on what I just told you on the previous slide. Here is the answer. The hallmark of case control studies is that it always starts with the outcome and you trace back to identify a particular exposure or several exposures. This is pretty much what how it usually happens. So you have your population of interest. Once you select a sample, right? I talked about that in the previous week for that presentation. You identify your population of interest, identify the sample from that, Then at baseline, you want to make sure that at baseline you have cases and controls. The cases always have the outcome of interest. Does that make sense? The cases would always have your outcome of interest, which is why you need to specify what exactly that is. And your controls will not have the outcome of interest. They might have the same exposure, but you want to make sure they do not have the outcome of interest. Again, in this situation, the controls don't always have to be healthy people. They could also have another condition, but just make sure that the particular condition that the cases have is not present, because you want to see, look to see, because if they have also been exposed to the same thing but do not have the outcome, then this is where you're actually able to answer your research question to identify why or how that happened. Again, so you see where the analytic characteristic of epidemiology plays a role. You're trying to track the how and why it happened. And of course, once you do that, you identify the exposed and those that are not exposed. Why use a case control study? First, it's used in understanding the cause of a disease or outcome of interest, right? Example would be the risk factors for death from a violent injury. The other reason why they are applicable is that they measure effective procedures or intervention, right? Because again, the procedure is already taking place, the intervention is already present, so now they're trying to measure the effect, right? So an example would be where you have screening programs, right? Are the screening programs effective? You can actually use a case control study to kind of backtrack to see if anything has changed in the outcome of interest. Investigation of disease outbreaks, and the classic example will be with what just happened with the coronavirus outbreak, which ended up being a pandemic. If you remember from a presentation from the first week of the course, I kind of told you what the difference between endemic, epidemic, and pandemic is. They all comprise of an outbreak, which would be a sudden increase in a particular event. But again, depending on how far wide it spreads, then you determine, which of those categories it will fall under. And this is actually used very often by the Centers for Disease Control, the World Health Organization, and all of that, because usually the outcome has already happened, and then we're trying to backtrack to see the exposure. So case control studies are very, very critical and very important in health epidemiology. It's also useful for diseases with a long latency period. So let's say you kind of want to test the association between a particular exposure and a particular disease, but let's say it takes a very long time before the person, the disease actually manifests itself. Rather than doing this prospectively, sometimes the quicker way to do it to assess this relationship so that you can implement an intervention will be using a case control study design. It's also useful for studying rare diseases where a large number of cases would be difficult to recruit, right? So if there are not that many, then it just makes sense for you to do a case control and kind of match them to a large control of a control group that does not have the actual outcome of interest. What are the strengths and weaknesses of a case control studies? Some of the strengths I actually just mentioned on the previous slide. You can relative to, and most of these comparisons are relative to cohort studies or experimental studies, which are high on the in ranks than case control studies, is that you can conduct them over a relatively shorter period of time, and we also use it to determine the etiology of disease. Again, that's why it's considered an analytic study design. You can also calculate prevalence of exposure, but you cannot calculate incidence, right? Reason being that incidence is a measure of new cases, while for case control studies, you're actually looking at something that's already existed, so you can only look at prevalence, which would be the total number of existing cases that you have available over that period of time. You also have the ability to study multiple exposures linked to one particular outcome, right? What are the major weaknesses of case control studies? One of the biggest weakness of case control studies is what we call recall bias. Reason being that the outcome has already taken place, and sometimes when you're trying to interview these participants, they may not actually be able to give you a fair, accurate account of the particular exposure. So in this case, this is always a major shortcoming, which is why we always say for any study you conduct, the results of every study should always be interpreted with care. Not to, because we know that nothing is always perfect. We live in a real world and not an ideal world, because if we were in an ideal world, then all of this would be a lot easier. The other risk that the other weakness or shortcoming of a case control study design is the risk of confounding. I'll talk about confounding in more detail as we move on in the course, but confounding is usually the effect of multiple other factors on the particular outcome. So most times the confounders are usually related to the potential cause or the potential risk factor and the outcome, right? So there's an interaction there. And in this instance, if these confounders are not addressed or taken care of, it's sort of difficult for you to determine what exactly was the potential cause. So say, for example, you want to look at the relationship between smoking and heart disease, but we also know that another condition is related to heart disease as well. And let's say we also know that alcohol consumption, again, these are just examples, don't take my word for it. We also want to we know that alcohol consumption is linked to heart disease as well, right? Depending on the amount of alcohol that's consumed. But we also have seen in studies that there's a relationship between smoking and alcohol consumption. So if you're studying someone who, let's say your study was to look at the relationship between smoking and heart disease, but you also have a particular person who's a smoker but also consumes a lot of alcohol as well, how are we actually able to tell whether it was the alcohol that caused the heart disease or it was more of the smoking? So this is an example of a confounding situation, okay? This is just an example I'm giving you, doesn't necessarily mean that's the case. So most times for case control studies, these are some of the weaknesses we run into and must do something to address them. And obviously, because again, it's retrospective in nature, we're unable to estimate the absolute measure, right? Remember I told you that absolute measures are usually a measure of risk and can only be done when you can identify new cases, and this is usually in a prospective setting. When we talk about cases and controls, some of the questions you also need to take into consideration is how you select your cases and your controls. Where do you get these controls from, right? Again, you have to think about this in terms of person, place, and time, right? What are possible problems with control selection? Think about all of these factors. How do we address them, right? When we know these problems have taken place, there's something called matching. There's a concept of matching, which is very important. And again, when we get into that arm of epidemiology where we stop talking about biases, I will bring this up in more detail. For now, I just want you to pay attention to the various study designs, and then we will address the biases that come up in epidemiologic studies as we move on. And the other question you kind of want to think about is it possible to have more than one control group? And the answer is yes. Usually in instances where like the condition is rare, I always advise, matching on a 1 to 2, 3, or 4 ratio, right? If you have a large sample to do that, like you have a large cohort to select from. Reason being that it kind of helps make this a little more representative, because usually the larger the sample, the better. But again, you don't want to make your sample too large that it becomes impossible or it's a waste of resources. You kind of have to want to make sure that you find that balance between them both. So it's possible to match with more than one control group. And the key thing is you want to make sure that the control group does not have the particular outcome of interest. That's important. They can have other conditions, but just make sure they do not have the particular outcome of interest. Concept of matching, it's a process of selecting controls so that they're similar in certain characteristics. There are two main ways to do this. Either you match them based on groups, or frequencies, or you match them on an individual level. So again, depending on how large your sample is and how rare the condition may be, then it's possible for you to do. So you do it based on what your scenario is and what's possible for you. And then problems with matching, absolutely. Nothing is perfect. That's one thing I want you to take home. Even though we tell you these are possible remedies, you have to kind of be cautious with how you go about it, because there's a possibility for you to overmatch. And when you overmatch, right, it becomes cumbersome, right? So you want to make sure that you're matching by as many reasonable variables as possible. I hope that makes sense. So I'll elaborate more on this as we move on to the next section of the term. Under case control study designs, we have several subtypes. We have what we call the case crossover study, where the actual case can be used as its own control. All right. I made a lot of reading materials available to you to kind of read about this a little more. We also have what we call a nested case control study. A nested case control study is usually derived from a larger cohort study. So most times what we already have a large prospective study that's been going on for years, and you take a subset of that cohort study, maybe to you identify another pattern to kind of study something within that cohort. Again, the same principles would apply in that you always start off with the outcome and work backwards or retrospectively to identify the exposure, right? You're trying to identify a causal relationship. But as I stated before, the fact that there might be a strong association doesn't necessarily mean that the relationship is causal. There are certain criteria that must be met in order for you to state that one thing causes another. All right, so again, same principle would apply here. You could use the general case control study where the cases are independent of the controls. You could do a case crossover where the particular case is its own control, or you do a nested case control where you derive the population from an ongoing prospective cohort study. Okay, one other key question that probably you might want to ask is, how do we identify controls? Most times controls can be derived from the same geographical area. They could be derived from the same family. They could be derived from the same clinic or hospital. The key thing is just make sure that they don't have the same outcome as the cases. In terms of epidemiologic measures in case control studies, like I stated earlier, we can measure prevalence, and also we can estimate the measure of association. For most of our analytic study designs, right, as they become more rigorous, we use what we call a 2x2 or contingency table, right, to help us set up our data in a way that we can actually estimate these measures, right? So here's an example of a 2x2 table where it's set up with the exposures, the exposure information on the horizontal axis, and the outcome on the vertical axis. So here we have the cases, we have the controls, and then you have the exposed and non-exposed. Regardless of how you choose to set up your table, right, there's certain things that you need to know, right? Because sometimes some of you memorize these formulas based on this table, but you have to know where each one lies, and I'll explain it on the next slide. Here is an example of the relative measure here. I already kind of told you how to explain this. So you always want to make sure that so you always want to make sure that your A, right, and your A is always the same thing as the exposed that have the outcome of interest. Your B always want to be the exposed that do not have the outcome of interest. The C, you always want to make sure that they're the non-exposed that have the outcome of interest. And the D would always be those that do not have the exposure and do not have the outcome of interest. Here's an example, here. So here we're talking about musculoskeletal diseases. This is what MSD stands for in this scenario. And we're looking at work history or work status. So in this case, the exposure is heavy lifting, right? So people who work in a role that requires heavy lifting, right? So the number of people who have a musculoskeletal disease that have a job history or status that involves heavy lifting was 112 for this particular time frame, right? So that's A. The number of people who do not have this musculoskeletal disease that have a job that involves heavy lifting, which is column B, is 176. The number of people who have the musculoskeletal condition that do not have a job that entails heavy lifting is cell C, which is 88, and the last cell will be those who do not have the musculoskeletal disease and do not have a work status or history that involves heavy lifting, is cell D, which is 224. When we sum all of this up, we know that the formula for the odds ratio, right, which is a relative measure of association, is the odds of exposure in the diseased or cases divided by the odds of exposure in the non-diseased. So what you want to do is compute the numerator first before you compute the denominator, right? An easy way to remember this formula is saying A times D divided by B times C. You can use this formula as long as you remember where in the cells, right, and what each cell stands for to do this. That's the key, otherwise you will get it wrong. So just make sure if in an exam or a test you're asked to create a 2x2 contingency table, regardless of how you set up your cases and your exposure, just make sure that you know what value, what each cell stands for. You know your A, you know your B, you know your C, you know your D. Otherwise, you might get this wrong. That's that for case control studies. I have given you a few examples. I've given you, a homework assignment as well, which should be due, I think next week. It would kind of require you to do these calculations. If you need help understanding these concepts, please ask me. I will make the time to sit with you to learn these calculations, because without a clear understanding of these calculations, you're claiming that you understand epidemiology is kind of erroneous. So you have to understand these concepts. So now let's go into cohort studies. What is the hallmark of cohort studies, and what steps do you take when designing a cohort study? Similar to the case control studies, the hallmark, the steps you would take are very similar, right? You know your purpose, whether you have the outcome or the exposure, things like that. But the hallmark of cohort studies, like I stated at the beginning of the presentation, is that you start with the exposure and you follow them forward in time longitudinally to see when and how they develop the outcome. All right, that's hallmark. Again, similar to the slide I presented to you, for case control studies, you can identify your population, identify the sample. You can see here it starts with the exposure, and then you go forward until they develop the outcome. Okay, same here. You categorize them as disease, not disease. Same thing. The 2 by 2 table would also apply here. Here's an example of a prospective cohort study. So like I stated, here's the exposure. You start with the exposure, you move it forward in time. Um, where it starts could be anywhere. They may already have had the exposure and you come in here and say, okay, but they don't have the outcome yet, then you could start here. Another way you could do it would be that you already start the study, but you just decide to watch them over time, and then you find out that they actually do have the exposure, and then the disease occurs. Again, the researcher has no control over what's happening here. All he or she is doing is observing what's happening in the natural environment. Um, Here's an example of what a retrospective cohort study looks like. Again, it says retrospective. I know that kind of sounds off because you would think it automatically applies only to case control studies. But like I stated before, the key difference between the both of them is actually when you begin your analysis, right? So it means the exposure and disease have already occurred, but you're actually you're doing your analysis starting from here, right? And then moving forward to here. Ambidirectional cohort studies are usually the instances where you combine retrospective and cohort study designs together. While this is not very frequently done, but there are instances where it actually happens. So there are a few out there, excuse me, there are a few out there that you would run into, but most times what you would frequently see is the prospective cohort study design. What are the characteristics of cohort studies? One, follow-up is the most critical and demanding part of a cohort study. Follow-up for mortality is usually easier than morbidity. Can anybody tell me why? Why it will be easier to follow up for death as opposed to the development of a disease? Since this is not an interactive session, I'll kind of give you a hint. Mortality, especially if you're dealing with, you're conducting your study in a Western country where, deaths are actually well recorded, it's easy for you to look up in the, I think, I don't know if it's called a death index or a database, where you could actually go in and type the person's name and it will tell you whether the person is dead or not, and you could always request a death certificate, as long as you follow the proper channels. Morbidity, on the other hand, is somebody may still be alive and they probably have the condition, but you don't even know, right? Maybe because you lose them to follow up, or maybe they don't even know when that they already have the condition, and had gone somewhere else, and by the time you find out, it might be a little too late. So usually mortality is a little easier to identify because if a person is dead, they're dead. When somebody has the disease, it's kind of a little hard if you're not following them very closely to identify when exactly the disease actually set in. Changes in level of exposure must be noted and recorded in cohort studies. So this is another characteristic or challenge that you encounter in cohort studies is, like I said, we live in a real world as opposed to an ideal world, and you have to remember that any research or study that involves human subjects is kind of cumbersome. Reason being that humans are versatile, sometimes we can be unpredictable. Someone who started off with a particular exposure, maybe over time, decides to, change the exposure status, right? Not necessarily because they choose to. Sometimes they might do it involuntarily, or sometimes they might just do it and not even realize it. So you kind of, if you're following them, you kind of want to make sure you pay attention to what they're doing. So say, for example, you were following people that smoke and you're looking forward to see what particular outcome they might have. People's smoking habits might change over time, right? So let's say you want to do your analysis to look at the number of cigarettes or the number of packs of cigarette they actually smoke, right? Assuming your focus is on smoking cigarettes. However, if you're looking at smoking in general, they might be smoking other kinds of things, marijuana, e-cigarettes, whatever, right? You want to kind of know that, right? And maybe the level at which they smoke changes. Someone may have started smoking only 1 pack per day, but by the time you get into 5 years down the line, they might smoke, 3 per day. You could also have some instances where someone actually switches status, where they stop smoking, right? So now they're no longer in that exposure group. The exposure status has changed. So you want to kind of make sure you're recording your data and you're performing your analysis based on those changes. The opposite could also take place where someone was not a smoker before, but suddenly starts smoking, right? So you want to actually record when the stats starts to see how this relates to your outcome of interest. What are the strengths and weaknesses of cohort studies? Kind of similar to what I have just said previously. Cohort studies obviously are the next in line to experimental studies when it comes to rigor. So it's definitely much stronger, and in some instances preferable to case control studies. One of those reasons is that you have the ability to measure multiple outcomes for a particular exposure. It enables you to study relatively rare exposures. Again, remember the hallmark of cohort studies is starting with exposure and going forward to find the outcome. Case control, on the other hand, helps you study rare outcomes of diseases. Cohort studies help you study rare exposures. You have the ability to calculate incidence in this case because again you're going forward to see when the actual event occurs. It also helps provide a clear temporal sequence of exposure and disease, especially those with a long latency period, right? Because you're following them over time, you can and if you're doing it properly, you can actually tell when exactly the disease manifests itself, and what that temporal relationship is. It also reduces the chance of recall bias, but it's not completely eliminated. Reason being that for different studies, for different topics, different populations, different scenarios, this might be difficult. What are the weaknesses? It's long in that it requires a long period of time, especially if it's a condition that has a long latency period. Another big problem that we run into is loss to follow-up, especially if it's a really long study. Again, I said humans are versatile. They move around, things happen. Someone may relocate. As the researcher, you have to actively be engaged or involved with your participants or your subjects to be sure that you do not lose them, in the study. It's relatively expensive compared to the other study designs that we've talked about. Reason being that you are using human resources. Most times you actually need humans to help you execute the studies. And I'll talk about some other important factors to take into consideration when you're trying to hire somebody to run a study. Again, you want to make sure that the person has good rapport with people, is a people person, and is actually able to relate well with your target population. It's usually not suited for studies of rare diseases because a large number of subjects is usually required, right? So that would be more applicable to case control study design. In terms of the measures of epidemiology that it would apply for cohort studies, we have the relative risk. We have incidence. You can also estimate prevalence as well, depending on how much data you have and what specifically you're looking at. And also we have the odds ratio. Again, the 2x2 contingency table, which I kind of went over on when talking about cohort studies, this would apply here. You would see it again when we get into the experimental study designs. It would apply there as well. So again, however you choose to set up your table is up to you. Just make sure that when you set the tables, right, you know where these values are placed. A would always be where you have the disease that have the exposure. B would always be where you have the non-disease that have the exposure. C, disease that do not have the exposure. And D would always be the non-disease that do not have the exposure. And you set it up this way. Remember the formula for calculating incidence would always be the number of new cases divided by the total population at risk. So most times when you see the data, you're always given a scenario form and you have to pick out these numbers yourself. You would not always be given a table and told, okay, this is what it looks like. No. This is why I keep saying that you need to employ critical thinking and logic to do very well in this course. Again, this is kind of similar to what I talked about for the case control study designs. Relative risk, you always make sure you have that the incidence for the exposed group is always computed in the numerator, and the incidence for the non-exposed group is always computed in the denominator. Once that is done, then you do it, and you always want to make sure that you are able to interpret your risk ratio. If it's greater than 1, you know there's a positive association. If it's equal to 1, it means there's really no evidence of an association between exposure and outcome, right? And then if it's less than 1, it means there's a negative association, and it's usually a protective factor. Here's another example for you. You can do this in your own time. It's similar to the example I gave you for case control studies, but the numbers have changed here. Again, MSD stands for musculoskeletal disease, and in this case is low back pain and shoulder pain, and you could take your time to do this as well. I already talked about this. You're interpreting the OR and RR. You should already know this. The other question you might want to ask is, can the relative risk be estimated from the odds ratio? The answer is yes, right? So if you remember when I was talking about the case control studies, I said the only measure of association that can be estimated from case control studies is odds ratio. However, for cohort studies, you have the ability to actually estimate both the relative risk and the odds ratio. And instances where you're actually able to estimate the relative risk from the odds ratio will be when the cases studied are very representative, when the controls are representative, and when the disease is rare. And these, when these criteria are met, most times the relative risk can actually be estimated from the odds ratio. I think that will be it for this presentation on the two major types of observational study designs under the analytic arm of epidemiology. I will give you all the opportunity to answer the questions on the discussion board, and we would actually be applying the concepts from these readings and from this presentation there. As always, feel free to ask me any questions you may have on there that I have not addressed in these presentations, and I will try my best to get back to you. I encourage you to do the practice exercises when you have time for you to actually be able to understand this a lot better. Having said that, I will see you on the discussion board.